complete satellite project. Now, because we're only a small nation with a relatively small population, we cannot simulate or emulate the American experiences or the international experiences that we've had in the past. So, being a small nation, our thoughts have obviously come round to a CubeSat. And it occurred to a number of people who were attending the ESA CubeSat conference or workshop at the beginning of this year, where there were 200 people in the audience and 40 presentations, something like that, of CubeSats from all over the world. That one of the routes that CubeSats are going, obviously many, if not all, certainly many, are university projects, but they're going into much more sophisticated technologies, trying to emulate in very, very small structures a full satellite with attitude control, with megabit communications, with cameras, with sensors, with everything. And technology has advanced so much with solar cells and whatever, that the thought came to us, I have to say in a bar, as probably all the best ideas come, that from an amateur communications or from a radio amateur point of view, it's really now possible to think about anyway, a single CubeSat that, as we all know, is a 4-inch cube, or is it a 100mm cube? I never quite. It's a 100mm cube, and it has to have a mass of less than 1 kilogram, into which you could put a transponder. Now, for us, the transponder is the holy grail. We're interested, some of us are interested in the telemetry, let's be honest, but most people are really interested in using it as a transponder. So we would have just a transponder. We wouldn't have anything else other than some telemetry, and I'll come back to the telemetry. So if we could cut out all the other things taking current and just have a transponder, have we got a power budget that makes sense? And on the back of a beer mat in the pub, the power budget made sense. In fact, the power budget made sense to say that we'd have a 1-watt transponder. I think reality in the subsequent time has brought the 1 watt maybe down to somewhere between half a watt and 1 watt, but still in the same order of magnitude. Now, to build just a transponder is a hard enough job, of course, but is very attractive to radio amateurs, but we need a wider audience to get some support for this CubeSat. So the thoughts then went to, well, the telemetry, really interesting, can be educational, and if we could get some simple material science experiments bolted on as well without using too much power or current, then maybe that would be worthwhile. And that's really what we've ended up with, is one CubeSat, but with 2 missions. And that's what this presentation is going to be all about. What we've also done since the beginning of the year and now is to conclude that the way forward is to do it quickly and efficiently and, dare I say, professionally. We, within AMSAT-UK, have got lots of skills, lots of talents, lots of enthusiasms, but not enough time. And therefore, what we've decided to do is to appoint a prime, I think in the jargon is prime contractor, system integrator, a commercial company. The contract is not yet let, so this is, what I'm talking about is the intent. One of the things that, of course, comes into building a satellite is money. And one of the advantages also of a CubeSat is that it's a bit less money than you'd need certainly for a bigger satellite, and much less money, and I'm looking at Peter as I'm saying this, much less money than we need to build a satellite or get a satellite to launch into high Earth orbit, GTO orbit, which I'm the first to put up my hand and say would be the ideal. But as I'll be talking about tomorrow, even ESA have had to come back from the idea of a GTO orbit for their ASAO project. Originally that was going to be a high Earth orbit or GTO orbit, and that now is, in inverted commas, only a LEO. So the funding side isn't completely taken care of, but is taken care of pretty well in terms of the build. Many of you in the room will know of the Radio Communications Foundation. That's a charity that is attached, or is not part of, but is related to the RSGB, Radio Society of Great Britain. And some of you would have noticed an announcement back end of last year about some funds that have been made available as a result of a bequest for amateur radio satellite project. So we have now got, just a couple of weeks ago, the agreement of the RCF that they're willing for most of those funds to be used for this project. That is to build the satellite up to the level of final test, integration, final test and verification. And we'll talk later about the launch. So this presentation is actually myself and Wuti Yan. David is quite involved, David Bowman has been quite involved with this project so far, but says he's doing enough other presentations. He would like to stay at the back of the room during this one, so his name is here. He's here in spirit and in body in the back of the room. So I mentioned the objectives, and these are the objectives that we defined and put up to the RCF with our proposal to them. And you will notice the precedence that the science education outreach has got. Without any doubt, our way to get funding these days from outside sources, even quasi-outside sources like the RCF, is to say education outreach. So that's what we've done, and the concept, which we'll describe later, is to have a very simple receiver that plugs into a USB port that can be used as part of the curriculum in primary and secondary schools or outside in science clubs. The secondary objective, our objective if you like, is to provide a linear transponder, a UV transponder, VHF downlink, 2 meter downlink, nice and strong, a UHF uplink which will hopefully not have too many taxis. So, in a bit more detail, a 1 unit CubeSat, 100mm by 100mm, using some standard bits. Those of you who are aware of the CubeSat world now, there are standard sub-assemblies or modules. Not only the structure, but things like the EPS. And probably the solar panels as well to match the EPS. It will have a deployable VHF, UHF antenna system, similar to, but not exactly as, probably as described, shown in that drawing. A BPSK VHF beacon, we need to coordinate compatibility with or alignment with SUTSAT-2 and ASAO, where maybe we could have not just 1 but 2 or 3 satellites all producing signals on VHF that could use the same receiver, might need different back-end software to display on the screen, but it's only software. I'm a hardware man, I can say that. No onboard computer. We don't think we actually need one. So a simple and command control board. Obviously necessary to switch various things on and off and to satisfy the requirements of the ITU. Passive attitude control based on Delphi C3. A UV transponder, which we talked about, probably 40 kilohertz. Is that still valid? That's the bandwidth, I think, yeah. And 1 watt is maybe a little optimistic. And a materials science experiment so that the telemetry is not only just temperatures and voltages that interest us. So there's a block diagram, and like all good block diagrams, it's too small, you can't read it, can you? Bad luck. I apologise. If I don't blind myself. That's a good one. I'm not going to belabor the point because I think we all probably know what a block diagram of a transponder probably looks like on a satellite. It's got UHF antenna, critical things, low noise amplifiers, bandpass filtering, down to 10.7 megs, a linear transponder with AGC. This is going to be simple. This has not got stellar. This has not got digital signal processing in it. It's only a CubeSat. Up converter to 145 megs, a high power amplifier and an antenna. Coming off the down converter is the command decoder, which will switch the EPS, control the EPS, what that switches on and off, switched outputs. There's a battery control regulator and 6 solar arrays feeding the battery control regulator. Various switches which relate to antenna deployment, so that does not deploy before it goes into flight. Various switches here to make sure that the thing does not power up, the satellite does not power up until it's left the deployer. All those switches are necessary to satisfy the launch authority. The first thing that obviously has to happen when the satellite deploys from the pod is that the antennas deploy, and that information is then added to the telemetry details. So here we've got a 400 BPSK with FEC telemetry encoder with some telemetry sensors here and the material science sensors there as well. That telemetry will then feed in obviously to the up converter at 10.7 megs and be transmitted. We will have yet to work out, but we will probably have 2 modes of operation. Telemetry only at high power, educational mode. So that simple receivers with an arrow or maybe even with a 19-inch bit of wire stuck in the antenna socket out in a field into a receiver that's plugged into the USB port will have the right link budget. Amateur mode, transponder operational, and a very low power telemetry. With FEC, we believe with a decent antenna, a decent receiver, you can get away with, for the want of a better expression, a very low power telemetry level of 10 or 20 milliwatts, so that most of the power will be available to the transponded signals. That was May. A couple of things have changed, but it still is basically where we are. So, educational outreach. We're calling it funcube. Is that the first time I've actually used that word? We're calling this satellite funcube. It's quite obvious why, because we see it as the in-orbit counterpart of GB4 Fun. The fact that GB4 Fun is also sponsored by the RCF, and that we could say this gives you your on-orbit counterpart to the GB4 Fun, which is the trailer outside you may have seen, which is for educational outreach, probably helps us sell the idea and get the funding from the Radio Communications Foundation. But it is not just a selling aid to us to get the money, it is so that Carlos has got lots of benefits and more to talk about, so that when he's out there talking to, presenting to students and kids, the space bit is really strong, and we'll have a miniature mock-up of funcube in his trailer, which he can demonstrate working, much as HowardSat had a couple of years ago. The material science payload is actually a very simple one, two faces or 2 parts of the structure of different colors, and looking at the temperature differential between the two. That's it in a simple sense. Anybody who's into science education will know what a Leslie's cube was, but it's a modern interpretation of that. This will be the first time that a CubeSat has been launched where the prime purpose is for education of primary and secondary school children. Up to now, all CubeSats have been university projects for relatively small groups of people. And by then, anybody who's going to be working at university or studying at university science, they're already in thinking, like us. What we're trying to do is to get more children at a younger age being interested in and aware of science. When do you take over this presentation? After this one. Thank you. It's the trouble of trying to do a double act and make it joined up. Okay, this is a slide that talks about the telemetry reception in terms of a school environment, showing an arrow antenna. That's a prototype, a one-off type receiver that has been done before that feeds telemetry into a USB port and the display which you'll recognize from Delphi C3. So we're building on some of the experience that Delphi C3 has had. Now, I'm now going to hand over to Wouter Jan. I don't think I need to introduce him. Everybody pretty well, I should think, has seen him before. Wouter's background is at the University of Delft, having been the leader or certainly a senior part of the team for Delphi C3, which was a 3U CubeSat a couple of years ago, and we'll hear more about that tomorrow. But he and a number of his colleagues within that project have started a company called ISIS, and they are, I suppose, what you would call our preferred bidders, because we have not signed a contract yet. But he's still a very good friend. Actually, I have to say we've developed a working process. You can't see it, but he's actually got a hat. And the hat's on a bearing, and he spins it round. The hat, on one face it says AMSAT, because he's an AMSAT-UK member. And every now and again he spins it round and it says ISIS. And it's worked pretty well so far. So, for the next short part of the presentation.
The dreaded handover event.
The dreaded handover event. You're on.
Thank you, Graham. Thank you very much. Okay. Now, Graham already explained to you about my two hats. Indeed, I am standing here with the two hats. For now, I put on the ISIS hat, which is also why I'm wearing our corporate T-shirt. Okay, I'll explain the project overview. Being a professional space project, what we have done is we have divided the project. Let's see, there we go. Into essentially a space segment, which is obviously the satellite, and a ground segment, but we've actually added something more, which is course material, educational course material that can be used actually in schools during courses, also in preparation of receiving telemetry from funcube, and doing experiments on the ground. For instance, the material science experiment, students can do a reference experiment on the ground and compare the results. Now, the satellite obviously consists of a satellite bus, which is built using off-the-shelf components, which are available from various suppliers for CubeSats. And the payload we have defined as the linear transponder, the control board, including the telemetry transmitter, and the material science payload. Well, the ground segment consists of the GB4 vehicle, which can be used for demonstrations, but also for commanding of the satellite, command and control. But we also envisaged a worldwide network of command stations formed by volunteer amateur radio operators worldwide, and of course the telemetry receiver kits. Now, the reason why these the course material and the telemetry receiver kits are put in brackets is that they have not yet been covered by the funding that we have applied for the project. But we are certain that we can seek additional funding to also complete these parts, especially when we make sure that the telemetry is compatible to ISAO or SUTSAT-2. Now, looking a bit more closely in operations. Like I said, we will form a volunteer team of amateur radio operators around the world, willing to do command and control of the satellite. Switching the mode, switching it to educational mode or the amateur radio transponder mode. GB4 of course, but also we envisage the use of the Genzo network, and this might actually be a very nice target also for Genzo ground stations, as are the Japanese satellites already at this moment. Now, speaking a bit about project organization. The payload, the satellite payload, is supplied by AMSAT, AMSAT volunteers. ISIS supplies the satellite bus, and also we provide integration support for the payload into the actual satellite bus. And furthermore, we will perform the qualification and acceptance testing. Now, these normally are separate tests. In a normal satellite project, you have separate models. You have a qualification model. Even before that, you'll have an engineering model. And then in the end, the flight model is being acceptance tested before launch. Now, for funcube, we decided to downscale this a bit, where we said, well, most of the bus components are actually available off the shelf, so these components have been qualified and acceptance tested already. So we do not need to make a qualification model for those. So what will happen is that the first activities within the project will be breadboarding of the payload, breadboarding of the linear transponder, of the material science payload, and a telemetry generator, which obviously will be tested. We'll have a review, and after that we'll start flight model production of the payloads. And after production, then that will be integrated with the flight model of all the other subsystems. So essentially, we're making the flight model directly after production of the payload flight models, doing integration of the satellite, integration and test, and then what we'll do is have a combined qualification and acceptance testing, and this test will test to the levels for various launch vehicles, so that the satellites actually, after this, it's ready and finished and sitting on the shelf, waiting for possible launch opportunities to come by. Speaking about the launch, I'll come back to that later also, but the launch has not been selected. Obviously, the idea is to build the satellite first, have it available on the shelf, and then seek possible opportunities. Whether it's a free launch or semi-free launch, we don't know yet at this moment. Well, I said I had the ISIS hat on, so just a short word on the company, but you may all be familiar with ISIS. We were founded in January 2006 as a spin-off of the Delphi C3 project, and since then we have grown considerably. At the moment we have about 19 employees in the company, about a 15 full-time equivalent of people, mostly engineers, working on small satellites, working on commercial satellites, CubeSats based, but also larger systems. And our role is system integrator, supplier of nanosatellites, but not only full satellites and missions, but also components, subsystems, structures, radio frequency components. And finally, we also offer launch services for small satellites, where we act as a launch broker. We actually have a launch coming up of 4 satellites, UE2, BSAT, ITU-PSAT, and SwissCube. Latest information on that is that the teams will be leaving to India next week to deliver the satellites, do the checkout of the satellites, and the launch is planned for somewhere towards the end of next month. Some of these faces you may remember from previous colloquia, and my role within the company is that of technical director. Okay, speaking about the launch. Like we said, the satellite is at the end of the project is fully built. It's essentially waiting and sitting on the shelf. And what we aim for also in the design of the satellite is for a typical low Earth orbit, sun-synchronous orbit, and the launch, of course, in one of these spots. The satellite will comply to the CubeSat specification. So any launch adapter that is available that can hold the satellite can actually be used to launch funcube. And the satellite will, like I said, be qualified for levels for most currently available and in the near future available launch vehicles, like Vega, PSOV, and other ones. Launch funding for the launch is not secured yet. It's not included. Has not been included also in the funds that we have been well, the RCF have provided right now. Depends a bit on what kind of launch opportunities there are available. We envisage that somewhere towards the end of the year there will be a decision on how we proceed also with fundraising for the launch. We may actually also approach educational institutions, but any input from the amateur radio community, of course, is also very much appreciated on securing funds for the launch. But there might even be a free launch available. For instance, the Vega launches, and so it's a matter of seeing what's available and then hopping on the train. Okay. Now, as part of this of the process, we have defined a possible timeline. Now, at the moment, we are somewhere here. Expect a contract to be signed this week.
Not much left this week. Maybe next week.
Who knows? Maybe at the SATgate meeting, we'll see. Well, we planned a conceptual design review in October, detailed design review April next year, and flight readiness towards October next year, because we'd like to have the satellite finished, of course, as soon as possible, to have the most launch opportunities available for it to be launched. And of course, putting on the amateur hat, I would like to see another linear transponder in space as soon as possible. Now, looking at possible opportunities for involvement from the amateur radio community, from AMSAT, things that we see, but I think this might also be some sort of interactive discussion, is in the space segment, the command decoder design. Like Graham mentioned, we're not planning to put an onboard computer in the satellite. We try to keep it as simple as possible. Actually, the working title of the project previously was KISS Cube, Keep It Simple, Stupid Cube. Telemetry development for generation of the BPSK telemetry generator. And of course, since there's a lot of technical expertise available within the amateur radio community, oversight and peer review on the whole course of the project. On the ground segment side, development of a receiver kit, development of a possible antenna, maybe the 19-inch whip or an arrow. We'll have to see. Telemetry software development, I think, is an area that is very suitable also for AMSAT to be involved in. And of course, the publicity aspect, which is of course a very important aspect in this project also, and management of the website. So please come and talk to us during the next during this day and the next and tomorrow, if you feel like you'd like to contribute to funcube and to make this happen. Okay, with that, I think that concludes the presentation, and we'll have some room for questions.
About 5 minutes for questions.
Perfect timing.
Very good timing.
There was one question that's come in over the web chat,
Yes.
and that question is, what is STEM? There was a caption up there that says STEM. That's an acronym from the educational world, which stands for Science, Technology, Engineering and Mathematics. Yeah, it's a sort of catch-all that's used when people are talking about, I suppose, non-arts subjects largely. So that's one question that we've answered from the internet.
Any questions from the floor? Go ahead, Pellic.
How are you going to implement the forward error correction with wired hardware?
We have not decided yet.
What was the
sorry,
question?
yeah.
If you just repeat the question so that people can hear.
Whether we're going to, the question is, are we going to implement the forward error correction using wired hardware, so hardware only? We haven't decided yet. As we
say that you're not going to have a computer on board. Computer control and logic is the same world, and you're not going to use it.
Indeed,
I want to see
yeah.
you wired hardware.
Okay.
Most probably, this might be implemented using, for instance, a big microcontroller or something like that.
It's
Yeah.
a computer.
Yes.
All right.
Onboard computer.
We'll not call it onboard computer.
I think the difference may be, from my sort of layman's perspective, is that it's not envisaged that this satellite will be capable of having software uploaded to it. I think the idea, if it is software, it's more like firmware.
Wait a moment. When he finds the first error in the forward error correction, he will upload the software too.
Later.
You could well be right.
Question in the front.
Well, one thing I can't understand why you might need forward error correction for the but I would like to ask about the choice of frequencies. Why did you choose that particular choice and not higher frequencies which would be more suited to a smaller satellite?
So why UHF, VHF?
Yes.
Okay, well, the question is, why did we choose for these frequencies, UHF uplink, VHF downlink, and not higher frequencies like, for instance, S-band or maybe even higher? I think the main answer to the question has to do with the fact that this is an educational satellite it has to be very simple to receive the downlink. And obviously on the VHF downlink, as people may know, as you may also know from the Delphi C3 signal, it's very strong, can easily be received on a handheld, and the Doppler shift is low, but it is audible, and it's very nice to demonstrate the Doppler shift on an SSB receiver. If we were to go to S-band, of course the Doppler shift would be much larger and it would be much more obvious, but then of course tuning and receiving would be much more difficult. especially for school children holding very simple receivers. So that's one of the reasons to go for UHF VHF. The other one, of course, also has to do with the linear transponder. UV transponders, there's not that much UV transponders actually in orbit. Unfortunately, the transponder on Delphi C3 died. Wouter Wegeler will talk about that tomorrow. And UV transponders are one of the most easy transponders to work with a relatively modest amateur radio station. So that's one of the reasons to go for these frequencies. And maybe a third reason also might have to do with efficiency of generation, of power generation on the low frequencies, which obviously is higher on low frequencies compared to high frequencies. And still, we may go to half a watt, perhaps even 1 watt of a transponder, but still it's a CubeSat, which of course is limited in terms of power.
Could I ask a question about, or perhaps make a point about frequency clearance in the UHF band? I operate from Cyprus, and Cyprus is very close to Egypt and the North African area. And the Egyptian military use our band for transmitting on certain frequencies. And at times I can't use a number of satellites with UHF uplinks because of the Egyptian military. So could I ask that some consideration be given to that, maybe some consultation with people that can tell you probably what frequencies the Egyptian military are tending to use?
May I amplify on this project?
Okay, sorry, the question, or the point was being related, sorry, the point relates to potential QRM on the UHF uplink in parts of the world.
Downlink, mostly on the UHF downlink.
As well.
Okay.
If you see in India, in Spain, in South America, Texas are using the
that is why we're using one of the reasons why, as well as the reasons that Jan has explained, why we're using UV, because V-band, VHF as an uplink, is totally impossible in many parts of the world, as Peleg is just describing. So,
when I switch the VHF amplifier,
yeah,
I'm overloaded with activity on VHF.
I have to say that's the first time I've heard of UHF interference on the uplink. So we'll have a conversation about that, please. Murray.
Yes, as you've had some background on this, can you say a bit more about what your solar cell budget is and what you're doing on batteries front?
What are we doing in terms of batteries and solar cells? We'll be using lithium batteries and the best solar cells that we can get for the price.
How many watts do you expect?
2.2 watts was a note that I remember writing.
What's the batteries for?
Batteries are for operating the satellite when it's in eclipse.
If you've got a computer, is that really necessary? Would it make it even simpler? Would it allow you to have more mass if you got rid of that?
Yes, but we're probably not mass limited.
Can I ask a question?
Sorry, I didn't repeat that question. The question was, would it be better to have do away with batteries, and then you'd have more volume and mass to do other things on board with?
Okay, my question is this: we've heard a bit about medium Earth orbits as opposed to low Earth orbits and high Earth orbits, and I know there are difficulties in doing it. If we had a launch opportunity to go to a medium Earth orbit, is this something that the satellite could cope with, do we think?
Repeat the question.
Okay, the question Jim asked is, there's lots of talk about medium Earth orbit, and if there's a launch opportunity for medium Earth orbits, and would the satellite be able to survive a medium Earth orbit? I think this largely depends on the actual orbital altitude, because the main issue there, I think, not so much might be the link, since we have quite some power for the linear transponder available, but it might be radiation damage in medium Earth orbit. So we'd have to look very carefully at the orbital altitude in order to decide whether we can actually use such a launch opportunity or not.
David Bowman is talking later today or tomorrow, I can't remember, about medium Earth orbits as an opportunity or an alternative. No doubt he can talk more about that.
Yeah.
So we don't steal his thunder.
That's, in theory, the end of your time. We'll just have one more question, if that's
Yeah,
okay.
there are a couple of questions on the internet, but there's one about why not a 3-cube, a 3-unit cube, and there's another one about the battery power, but I think that was already answered. And about the forward air correction, has there been decided what to use for forward air correction?
Okay. Well, first question is, why not go for a 3-unit CubeSat? Why a 1-unit CubeSat? That mostly has to do with launch costs, because these launch costs scale with the mass of the satellite. And essentially you can say that launch cost for a 3U typically 3 times the cost for a 1U. Furthermore, we think we can fulfill all the objectives that we have set ourselves within a 1U. We think we have enough power to run the linear transponder in a 1U. We were also able to do so in Delphi C3, and that transponder board only took 1.5 watts. So that would be perfectly feasible in 1U. So that's also has to do with the philosophy to keep it as simple as possible. Second question has to do with the forward error correction. What type of forward error correction we're planning to use? We don't know yet. I think this largely will depend also on possible compatibility with SUITSat2 or ISEO. And that's a decision that has not been made at this moment.
Okay. I'm going to cut the... Oh, well, it's your time you're going to be using because you're the next speaker, Freddie. So
one quick comment about the MEO orbit. You might have to consider lifetime as well.
Yes.
Beyond 800 or so, you'll be there forever.
This is debris mitigation lifetime that Freddie's talking about. Okay.
Okay. Let's wrap it up there. Thanks very much.